in space here. Oh, there's one. Let's get the other one. The cross product of these two vectors is a third vector. If this is u vector and this is v vector, the cross product is actually going to be a third vector. Produces a vector that is perpendicular to both original vectors. So a little tough for me to illustrate here, so you have to get your imagination hats on. But if we were to cross product u and v, somehow there'd be a vector popping up out of the plane that those two are in. That's going to be perpendicular to vector v, but simultaneously perpendicular to vector u. Well, that's a terrible perpendicular sign there, but you get the idea. So this is what u vector cross product with v vector would give us, would be a third vector in a totally different direction. It's coming up out of the plane that contains u and v. And so if you have two vectors, and depending on what they represent, this third vector might be something particularly useful. We might have a torque question to find the moment of torque done by a force around a point P. That's a pretty common application of the vectors cross products, because when you figure out the moment of that torque, it's either into or out of the plane where of the vectors that contain both the moment arm and then the force that you're applying. So for those of you who are in physics, you may have already even talked about this, finding the moment of torque around a point P. But that's a great example of how we might use cross product of two vectors. Sorry. So because we're now moving into three-dimensional space, v vector and u vector are going to be, they're going to be like u1, u2, and u3. And v vector is going to be like v1, v2, and v3. Or I like to write them in IJK form for this, and you'll see why in just a minute. So this would be like v1 times the I vector, v2 times the j vector, and v3 times the k vector. And this will be u1 I vector, and u2 j vector, and u3 k vector. And so the cross product that we're going to get is going to be using a 3x3 matrix and the determinant of that 3x3 matrix to come up with the IJK form for this new vector over here that I'm calling u cross with v. So everything here is done in three-dimensional space. Now, if they happen to be in the XY plane, that's fantastic. But just remember then that your cross product is not going to be in the XY plane. It's going to be perpendicular to the XY plane. So, if this is the plane, that contains u and v, then your new vector is going to pop out of that plane either this way or into the plane going the other direction. So even if you're in the XY plane, u and v are coplanar no matter what. you just have a 0 for one of those three coordinates, either v1, v2, or v3, depending on which plane you're in. If you're in the xy plane, then obviously v3 and u3 are 0, but you still put them in. And so the cross product then, let's go over here. U vector crossed with v vector, it's going to be a determinant and the first row of the matrix is ijk. And then the second row of the matrix, u1, u2, u3, and the third row, v1, v2, v3, just like that. And so by finding the determinant of this matrix, we will find a vector and guaranteed to be perpendicular to the original two vectors. It's orthogonal to both. So I'm going to find this vector just in sort of general form, and then we're going to do an example with some numbers to it. And then the application questions that we have for are for Thursday's assignment. I might have to put out a second video for this week with those in there, because I can see we're going to run out of time here pretty quick. YouTube limits me to how long my videos can be when I put them up there, so I'll have to edit these down a little bit. Okay, I don't care which method you choose to do the determinant with here. If you're a diagonals kind of person, then copy the two columns over, the I column and the J column get copied over right here, and start multiplying your diagonals. I am more of a reduction along minors guy, so I'm going to do it that way. But it really is not, it's not wrong to do this with diagonals. So my first minor is going to be the I vector minor. And you can see that that's U2, U3, V2, V3 for its minor. Okay. And then my next minor will be the J minor. Now J is in row 1, column 2, so it's odd. So that's minus J times its minor, which is U1, U3, V1, V3. And I've got my little drawing in the way here. Oops, so I'm going to get that out of the way. So we can get our third minor up here. This is going to be K vector times U1, U2, V1, V2. And so the I vector coefficient then is going to be U2, V3 minus V2, U3 times I vector. The J vector coefficient is going to be U1, V3 minus V1, U3 times J vector. And then the K vector coefficient is U1, V2 minus V1, U2 K vector, like so. So whatever those numbers turn out to be, those will be the coefficients for the I, J, and K vector. And no matter which vector you try it with, if you want to dot product our vector with either U or V, you should get 0 because it is going to be perpendicular. So, all right, that's all fine and good. That's the theoretical way to do it. But we're going to actually put some numbers to this. So I'm going to do a quick example here. So let's see. Oh, I don't want to. No, I'm going to jump to the next page. If you are still taking notes on that, I will come back to that in just a second. My u vector is I minus 2k minus 2j. Racer, where are you? There you go. Plus k vector. And my v vector is 3i plus j minus 2k. And so I'm going to start off by finding the cross product of those two vectors. U vector cross with v vector. So again, top row of the matrix, ijk. The next row, since u is first, is going to be 1, negative 2, and 1. And v is second, so it's 3, 1, negative 2. And so my cross product vector, I times negative 2, 1, 1, negative 2, j times 1, 1, 3, negative 2. Oh, whoa. And my last one, k vector times 1, negative 2, 3, and 1. And so what this will do is it'll give me my vector now. I vector is going to get multiplied by, let's see, negative 2 times negative 2 is 4, minus 1. Negative j is going to get multiplied by negative 2 minus 3. And k is going to get multiplied by 1 minus negative 6. Right. So our resulting vector here is 3i plus, let's see, 5j plus 7k. And that is the vector u cross v. And it is going to be, you know, however these two guys are oriented in the three-dimensional space, this vector will be perpendicular to the plane that contains those two vectors. Now you may have noticed when I was writing that down, I said, okay, u is first, so it goes next. Because if you change the order, v dot u, any guesses? Check it out. I's going to be multiplied by 1, negative 2, negative 2, 1 now. Negative j is going to be multiplied by 3, negative 2, 1, 1. And k is going to get multiplied by 3, 1, 1, negative 2. And I won't go through them all, but notice that i's coefficient now, right, is 1 minus 4. So you're going to get negative 3i. Negative j's coefficient is now 3 plus 2. So you're going to get negative 5j. And obviously k is going to be a negative 7k when you multiply that. Oops, I put else I didn't mean that. So by cross producting in the other order, we get a vector that's still perpendicular to both those vectors and perpendicular to the plane that's in them. It's just going the opposite direction. So if this was my plane